In today's episode, you will learn how to make a long-range wireless battery voltage monitoring system using Arduino Nano 0 to 25 volt voltage sensor, HC05 Bluetooth module. For the demonstration purposes, I will measure the voltage of these 12 volt and 5 volt adapters. I started off by measuring the voltage using a digital multimeter to make sure if I can read the same voltage on my cell phone app designed in Android Studio. Next, I connected the 12 volt power supply with the 0 to 25 volt voltage sensor. Next, I powered up the receiver side circuit using a 5 volt regulated power supply. As you can see, currently the Bluetooth module is not connected with the cell phone, and this is why the LED is blinking at a faster rate. I have already paired this module with the cell phone and it's ready to be used with the Android cell phone application. Open the Android cell phone application. Click on the search for paired devices. In the list, select your Bluetooth module and finally click on the connect button. When the app is connected with the Bluetooth, the LED start blinking at a slower rate. Anyhow, you can see I can monitor the battery voltage on my cell phone. The value is approximately the same. You can adjust this value by changing the correction factor value, which I will explain in the programming. There is no physical connection between the receiver side and the transmitter side. If the transmitter is turned off or you are not in the range, the connection lost message will be printed. At this point, you can go and check your transmitter module if it's working properly, and you can also check the range. Anyhow, when you turn on the transmitter and the other transceiver module is in the range, you will again start receiving the data. The receiver side is completely portable and wirelessly communicates with the Android cell phone application through the Bluetooth module. So how exactly this works? The Arduino reads the voltage sensor which is connected with a battery in the Arduino, then sends this data with the help of nRF24L01 to the receiver nRF24L01 module, and then the Arduino takes the data, and then the Arduino through Bluetooth module sends this data wirelessly to the Android cell phone application. I kept performing the experiments. With this project, you can monitor voltages between 0 and 25 volts. This time I'm going to measure the voltage of a 5 volt adapter. This is not exactly 5 volts adapter. The output of this adapter fluctuates between 5.1 and 5.3 volts. Perfect, I'm getting the same exact value. Now to test the range, I kept the receiver away from the transmitter circuit and I'm still receiving the data without any problem. Now again I'm going to connect the 12 volt adapter. This time you can see the 12 volts. I kept performing the test to the receiver circuit. I placed it a different location away from the transmitter, and then I was away from the receiver circuit, and still I was able to monitor the voltage without any problem. In today's episode, you will learn how to calibrate and use this low-cost pH sensor kit from the DIY More. I started off by calibrating the pH sensor using the Arduino board. Once the pH sensor perfectly calibrated, then I started by measuring the pH value of the distilled water and displayed the values on the serial monitor. I performed a series of tests using different liquids, and once satisfied, I further modified the code to display the pH value on the OLED display module. Again, I started with the distilled water and waited for around 30 minutes to check if there can be any fluctuations in the pH value. The pH value remained almost the same. Next, I added some lemon juice to the water and I was amazed with the result. As you know, the pH value of the lemon juice is 2 and the value on the display, as you can see, is almost 2. Next, I cleaned the pH sensor probe to measure the pH of the milk. For the milk too, I got the correct pH value. I also added lemon juice to check if the value will drop. As this is a getting started tutorial, I will try to explain the maximum basic things. In this tutorial, we will cover number 1. DIY more pH sensor kit pinout and technical specifications. Number 2. pH sensor calibration. Number 3. Complete circuit diagram explanation. Number 4. pH sensor Arduino programming. And finally, number 5. Testing. In today's episode, you will learn how to make and repair any type of lead acid battery using new and old positive and ground plates. I will also explain what are the necessary tools and how to use them. I will also explain how to make the battery internal and external terminals. I will also explain in detail how to internally connect the positive and ground plates. In the end, I will also explain how to prepare electrolyte for the battery using sulfuric acid. The process of making the electrolyte can be really dangerous for the beginners, so I highly recommend purchase the ready-made electrolyte for the battery or make the electrolyte at your own risk. After watching this tutorial, you will be able to make a complete new battery, and you will also be able to repair any type of small and large lead acid batteries. This way you can save a lot of money and you can also start your own business. In today's episode, you will learn how to make a long-range wireless industrial temperature monitoring system using Arduino Nano, nRF24L01 transceiver modules, industrial temperature sensor capable of measuring the temperature up to 1000 centigrade, and an I2C supported OLED display module. If for any reason the transmitter is turned off or the transmitter is not in the range, then connection lost will be printed on the OLED display module. There is a timer that monitors the data, so if the data is not received for 1 second, the connection lost will be printed. Then you can go ahead and check your transmitter side. You can also use the smaller nRF24L01 transceiver module on the receiver side. So it really doesn't matter whether you are using the smaller nRF24L01 modules or the bigger ones. If you are using the NRF transceiver modules for the first time, then I recommend you should start with the smaller nRF24L01 transceiver modules. So this is the wireless industrial temperature monitoring system, which is very easy to build, and if you watch this video from start to the very end, I'm sure in the end you will be able to add multiple sensors on the transmitter side. This way you can make some advanced level projects. In this tutorial, you will learn how to use the Max 3100 pulse oximeter with Arduino Nano and display the heart rate and blood oxygen on a 16:2 I2C supported LCD module, and also send the blood oxygen and heart rate or pulse rate values to the Android application designed in Android Studio using the wireless Bluetooth technology. The heart rate or pulse rate or heartbeat is measured in BPM, which is also known as the beats per minute, while the blood oxygen concentration is measured in percentage. In this tutorial, you will learn how to make face recognition based door lock control system using ESP32 camera module and a 12-volt electronic lock. For the authorized person, the onboard white LED is turned on and also the electronic lock is opened. Any purse can be converted into a smart purse with a women's safety device provided with a wireless receiver, GSM module and a GPS module. All these modules are interfaced with the Arduino Nano. All the electronics are powered up using the rechargeable LiPo battery. The female safety device inside a purse, handbag or school bag can be operated using this small wireless transmitter. This small wireless remote controller should not be placed inside the purse and should be placed somewhere safe. In an emergency situation, all you need is to secretly press a button. This will send the victim's GPS coordinates to the family member in a text message consisting of the Google's Map URL link consisting of the latitude and longitude information. If the kidnapper or someone else snatches the purse, wait for the right time and press the button. The YK04 transmitter and receiver modules can communicate up to 50 meters as per the datasheet. I performed a series of tests and it worked perfectly. This is just a prototype model. The size can be further reduced by using the small GSM and GPS modules. In today's episode, you will learn how to make an IoT Smart Irrigation system using Node MCU ESP8266 Wi-Fi module, 15 km LoRa transceiver modules, Arduino Nano, and a capacitive soil moisture sensor V1.2. This area is around 6 kilometers from my friend's house. Currently in this area, no GPRS signals are received, and as per my friend's demand, he wants to monitor the soil moisture on his cell phone. As no internet is available in this area, so we cannot use any internet supported devices like the Node MCU, ESP8266 or ESP32 modules on the transmitter side. So due to the 6 kilometers long distance, we will have to use long range radio frequency modules. On the transmitter side, LoRa module is used with the Arduino Nano to send the sensor's data to the receiver. On the receiver side, the LoRa module is connected with the Node MCU ESP8266 Wi-Fi module. At this point, you can directly connect the Node MCU module with the laptop and monitor the data on the serial monitor, or you can design a cell phone application and monitor the data from anywhere around the world. For the demonstration purposes, I connected a variable resistor. I can monitor the values in real time. Notification messages are sent when the sensor value increases above or decreases below a certain predefined value. These values are sent from the transmitter side through a 15 km LoRa transceiver module. On the receiver side, another 15 km LoRa transceiver module is connected with the Node MCU ESP8266 Wi-Fi module, which receives the data and then send it to the Blynk application. After performing all the basic tests, finally I soldered all the components on the Vero board and fixed the transmitter side in a waterproof plastic enclosure. The capacitive soil moisture sensor was working great. There was no disconnection and I was able to receive the moisture values in real time. The type of the capacitive soil moisture sensor I used was later damaged due to the exposed electronic components. That's why I ordered another capacitive soil moisture sensor which is completely waterproofed. I have been testing this IoT Smart Irrigation system and is working perfectly without any problem. In today's episode, we will control the same CNC Shield using the Node MCU ESP8266 Wi-Fi module. This way the two hybrid stepper motors can be controlled from anywhere around the world using the cell phone application designed in Blynk. You will learn a lot of new things in this video, like for example, how to control the speed and limits of the stepper motor using the sliders, how to manually adjust the starting position of the stepper motor using a potentiometer, and how to control a stepper motor using the joystick on the Blynk application. This button is used to switch between the two stepper motors. When this button is turned off, then you can manually control the Y stepper motor using the joystick. There are no limits. You can infinitely rotate the stepper motor in forward direction and in the reverse direction. While the button is turned off, you can also set the starting position of the X stepper motor using the potentiometer or variable resistor. When you are done with the adjustments, finally you can turn on the button. This will activate the X stepper motor. Now these two sliders can be used to adjust the limit and speed of the stepper motor. You can change the speed and limits in real time. In today's episode, you will learn how to make IoT-based water quality monitoring system using TDS sensor, DS18B20 waterproof one-wire digital temperature sensor, and ESP32 Wi-Fi plus Bluetooth module by the Espressif Systems. As this project is based on the IoT, Internet of Things based technology, so the EC electrical conductivity and temperature can be monitored from anywhere around the world using the Blynk application. In today's episode, you will learn how to make an IoT Internet of Things based notice board using Node MCU ESP8266 Wi-Fi module, MAX7219.matrix 8x8 LED modules, and Blynk application. The scrolling text message on the 8x8 LED matrix can be updated at any time from anywhere around the world using the Blynk application. The scrolling speed of the text message can be controlled using a variable resistor or potentiometer. How to make a smart house and control electrical loads using the ESP32 Bluetooth and an Android cell phone application designed in Android Studio. So later in the end, I will explain how to use the ESP32 Bluetooth and Wi-Fi together to make smart house or home automation system. You will be able to control the electrical loads using the Android cell phone application without using the internet, and moreover, it's best for the short range communication. For the worldwide control system, we will make an application using the Blynk IoT platform. With the help of this application, the electrical loads can be controlled from anywhere around the world. For every load to control, strong passwords are used which can be manually entered using my designed Android cell phone application, or you can make your own application, add some buttons, and you don't need to write the passwords. In today's episode, you will learn how to make an advanced level countdown timer based on the Arduino 16x2 I2C LCD, 4x3 matrix keypad, and a one-channel relay module. With the help of this countdown timer, you can control different types of electrical loads, like for example light bulbs, heaters, water pumps, washing machines, fans, etc. In fact, this countdown timer can be used anywhere where you need to control anything on the time basis. As you can see, for the demonstration purposes, I have connected a 220 volt AC light bulb, which of course can be replaced with different types of other electrical loads. This countdown timer is very user friendly. Let's say I want to turn on this bulb for 10 seconds. Enter minutes is 0 and press the asterisk key on the keypad. Now enter seconds and again press the asterisk key on the keypad. As you can see, the light bulb has been turned on. Now this bulb will remain on for 10 seconds. In today's episode, you will learn how to make an advanced level IoT based real-time earthquake detector and early warning system using multiple node MCU, ESP8266 modules and SW-420 vibration sensors. With the help of this project, the earthquake detection system can be installed in every city, which will make a complete wireless network. And every earthquake monitoring device, which is represented by the green dot, can be monitored in real time using the IoT platform. Due to the real-time monitoring, we can easily predict in which direction the earthquake waves are traveling. This way the people can be informed in time before the earthquake hits that area. Each earthquake sensor data will have the date and time information as well. For the practical demonstration, I have only considered two locations, Peshawar and Nowshera. Later you can increase the number of locations. Each time the vibration is detected, the value on the chart is updated in real time, and if the vibration crosses a certain predefined value, emails are sent to the concerned person along with the date and time information. In today's episode, you will learn how to make a word clock using a 10.1-inch HMI TFT LCD display module by the Stone Technologies and a Node MCU ESP8266 module by the Espressif Systems. This is the smartest word clock. You don't have to enter the hours, minutes and seconds manually, and there is also no need to use the RTC real-time clock module. All you need simply select a time zone on your cell phone application designed in Blynk, wait for a minute, and the time will be updated. This is the Pakistan's standard time. These are the hours, these are the minutes and seconds. The time is synchronized with the server timing after every 1 minute, due to which you will always get the exact time. If due to some issues the Wi-Fi is disconnected, the word clock won't stop working. The minutes and seconds are incremented automatically and will continue to work. When the Wi-Fi connection becomes active, the word clock is synchronized again with the server time. Let's select a different time zone. I'm going to select New York, America. As you can see, the time is updated and now I can keep track of all my favorite TV shows and movies from Pakistan. In today's episode, you will learn how to make the most efficient password protected door lock security system using Arduino and a keypad. When you enter the correct 4-digit password, the door is opened for 5 seconds. Currently the password is 1234, which you can change in the programming. You can even select a password consisting of more than 8 digits. I have checked this password door lock security system many times and it worked perfectly. If a wrong password is entered 3 times, the person is locked out for 5 seconds and an LED is turned on, which can be replaced with a buzzer. The number of wrong attempts can be increased or decreased as per the requirement. In today's episode, you will learn how to control electrical loads using 10.1-inch HMI TFT LCD display module and Arduino. The control commands are sent serially from the HMI touchscreen display module through the MAX 232 board to the Arduino. The Arduino then turn on and turn off the desired load depending on the command. Using the same button, you can turn on and turn off the load. For the demonstration purposes, I have connected 220 volt AC light bulbs, which you can replace with other AC or DC loads. Be very careful while working on the 220 volt AC as it can be really dangerous. Wear protective gloves. This DIY IoT Power Relay based on the ESP32 55 plus Bluetooth module can be used to control the high power devices like, for example, water pumps, air conditioners, heaters and other high ampere loads. The best thing about this IoT Power Relay is that it can be controlled from 2 different sources. The best thing about this IoT Power Relay is that it can be controlled from anywhere around the world using the Wi-Fi technology. So it really doesn't matter how far you are. If you have the internet connection, you can turn on and turn off the power relay. The cell phone application is designed in Blynk, which I will explain in a few minutes. The same power relay can also be controlled over the Bluetooth using the cell phone application designed in Android Studio. I have a very detailed tutorial on how to design your own Android cell phone application using Android Studio. I will provide a link in the description. For the demonstration purposes, I'll be controlling a water pump using this IoT Power Relay. To control the water pump over the Wi-Fi connection, all you need is open your IoT Power Relay cell phone application and start controlling the water pump. This application should only be used if you are far away. If you are at home or near to the power relay, then you can use your Bluetooth application to control the water pump. This also eliminates the risk of electric shock as there is no need to physically operate the switch. The IoT Power Relay can be used to control the water pump without any risk. In my last tutorial on the Google Firebase database, I explained how to send a sensor value from the Node MCU ESP8266 module to the Google Firebase database. In today's episode, we are going to make the same exact thing using the ESP32 Wi-Fi plus Bluetooth module by the Espressif Systems. This is the same exact company that created the ESP8266 series of chips, modules and development boards. Unlike the ultrasonic sensor, this laser sensor module can also be used for monitoring the water level. It can be used in security systems, obstacle avoidance robots and so on. Anyhow, I continued with the experiments, modified the code one more time, and this time I was able to control a 110 or 220 volt AC light bulb. Make sure you wear the protective gloves as 220 volt AC can be really dangerous. You can replace this bulb with a water pump or any other electrical device that you want to control. The bulb is turned on when the distance is less than 5 inches and remains on until the distance is greater than 10 inches. While performing the experiments, when the laser sensor was facing the camera, I could see this light coming out of the sensor, which you can't see with naked eyes. If you have this sensor, go ahead and check.